Hello DonkeyCar community! Today I want to show you how you can train a neural network with a GPU even though you don't have a GPU locally available. You can do this with a service provided by Google called Colab. Colab is a zero configuration cloud-based service where you can execute Python in your browser with free access to GPU. We start from a blog post created with fast pages. The whole process is going to be in 6 steps. The first step is to create a DonkeyCar environment. The second step is to supply the data. The third step is to upload myconfig.py. The fourth step is to train the model, where the fifth step is to transfer that model back to the car and check the quality of the model. The sixth step is a bonus, where we show on which sections of the image the neural network was focusing during training. So let's open the blog post in the Colab environment. We have the left-hand side, we have the outline. Right-hand side, you have text and code. You can run each cell by clicking on a triangle. Because this Google Sheet wasn't authorized by Google, you have to click the run anyway to run the cells. So the first step is to install TensorFlow version, because your DonkeyCar expects that you have the TensorFlow version already installed. So that takes a few seconds. Because it's run in the cloud, it runs pretty fast. We can then follow all the steps which are outlined in the DonkeyCar documentation. The link for the DonkeyCar documentation is provided below in the description. So we can check which version of TensorFlow we install. It's 1.15. We can then go and git clone the DonkeyCar repository onto our Colab space. Here we can see the files. There you see right is the DonkeyCar folder. All this takes a few seconds as well. So now we install the libraries which are needed to run the DonkeyCar framework. That again is pretty fast because we all run in the cloud. And then we have to create our DonkeyCar project just as outlined in the documentation from the DonkeyCar project with all the necessary folders and files. We have a few options if you want to supply data in this Colab sheet. The first option is the one I want to show you today, is to use your own data. Then there are 2 more options where you can upload data from the GitHub, and there's 2 GitHub repositories with data to be trained. One is from the Robocar Esslingen meetup, and the other one is from the Connected Autonomous Mobility meetup. Today we want to focus on supplying our own data. If the data is sitting on your Raspberry Pi, first thing you do is to zip the data, because that makes it easier to copy it to your PC. You can then copy it to your PC as outlined here. In my case, I already copied the data from the SD card of my Raspberry Pi to my local PC, and then I copied it to my Google Drive. So my tab name is here, so I create a variable with the tab name. And then I mount my drive so I can copy data from my Google Drive to the Colab instance. I have to log in. I allow all those. I copy my authorization code. Press return. And then I can access my Google Drive because it's mounted in my Colab instance. So I can copy my data which sits in the Google Drive. And if I go here to my files folder, I can see all the data being copied to my data folder. Because it's a zipped file, I have to unzip it. And then I can rerun these cells. The output is still given from my last run because this is what I have in the blog post. So I just update those outputs. So we see this is a picture which is being taken in the video while recording the training data. So if I want to check the quality of the data, there is a command called tophist, which creates a histogram of the steering angles. And we want to have a balanced left and right steering angle. You'll see there is more left angles than right angles. That's due to the nature of the course, and we mainly drive straight, but that's also due to the nature of the course. So now we're quite happy with the data we supplied. If you don't have your own data, you can, as I mentioned already, use the supplied data on a GitHub, by Robocar Esslingen, or by the meetup Connected Autonomous Mobility. Now we need to use the same myconfig.py file for training a neural network, which was being used for recording a training data. So in the myconfig.py file, there are plenty of parameters which needs to be set to your liking and according to your car. I just copy mine over from the Google Drive, and I can look at it by double-clicking here. That opens. So this is my specific parameters for my car. I use the Atom Optimizer. We're going to use a pre-trained model, and I want to retrain all the layers, so I put the freeze layers to false. So the next step is to upload our pre-trained model. Again, from the Google Drive, I upload the base linear.h5 file. And if I want to see the structure of the model, I can use the plot model method from Keras. Takes a little while, and then it shows us a graph of the model, which starts with an input layer. It crops it to the specific dimensions we specified in myconfig.py. There's a few 2D convolutional network layers. Then we flatten here the output of the last 2D convolution layer. We have dropout in between. We have two more dense layers, and then we have one output for the steering and one output for throttle. So for training, we use the train parameter for the manage.py file, and we just run it like so. One of the first outputs is all the layers and the number of parameters of the model. Since we didn't freeze any layers, we train almost all parameters right now. The training will take a little while. Once it's finished, I'm back. So now the training has completed. Let's check the result. It took about 3 minutes to train. We check the model by looking at the loss, and we can see the loss of the training and validation is pretty similar, doesn't diverge too much, so probably not a case of overfitting. But maybe more telling is to compare the predicted steering with the measured steering. And there's a utility in the Donkey Cow framework which is called tupplot and can be run with this command. So once that's finished, you get this plot, and it shows you the user angle and the pilot angle. So the user angle is the one which was recorded, and the pilot angle is the one predicted. So that's a pretty good match. For throttle, there was a constant throttle during training, so the prediction is not very meaningful. So if we're happy with the model we got, we then copy the file from our PC or Mac to the Raspberry Pi. We can use FileZilla or SCP, depending on what you prefer. So the sixth step is the salient object visualization. If you execute the commands in the Colab sheet, you end with a video like this, where you can see on which sections the algorithm was focusing on. It should be the marks on the track, but you can see it's quite a bit of distraction on the surroundings. So one option to deal with that is to crop your images before training. So that was all for today. I hope you enjoyed it. If you liked it, please leave a like below and have much more fun with your donkey car.